Hello, this screen recording will be used to demonstrate my ability to find a Pearson's correlation coefficient, as well as creating a scatter plot graph for two columns of data, which I'll be finding the relationship between. Along with the Pearson's correlation coefficient, the p-value, the significance value will also be found. So first, I need to open up my Jupyter notebook, which I will be working on, and let's come out to a different page. Perfect. First things first is I need to import all the libraries that I want to be using, and to make my life easier, I created a quick clipboard, a quick copy that I can always put in, makes life a lot easier. And similarly, I have another one for um, this so that I'm able to read my Excel document with the data inside of it. Um, Another area is that I will be needing to copy the path of the Excel document in order for me to actually be able to import it and use it. And this, very quickly, PD is my pandas library, and this is just saying that the new data frame I'm creating will be read by pandas, and it's a function within pandas is recognizing this as an Excel file, and that it will be able to read the Excel format. Also, I've put a raw string terminology there because I think if you noticed, the copy path once pasted starts off with this C colon. However, I face issues with that because in my paths I have backslashes, and with just this, that causes these backslashes to be recognized as escape codes. And to go around that, I put that R in front to turn it into a raw string, so that it all just gets recognized as literal characters. So quickly, I can see all the uh, my data frame. It shows you all the data I have. We'll be looking at the relationship between muscle mass percentage and peak power found in my experimental control conditions for my dissertation. I'd like to quickly format and get rid of these unnamed. So to do that, I will have to use another pandas library function. This will just turn all the unnamed columns and cells, hopefully, and it will remove them. Yeah, perfect. And now, since I will be only working with I first have to find the difference between the two peak power columns, peak power variables. So I'll just need to create another data frame to make my life easier. I'll call it dissertation peak power, where it would take the dissertation columns, the dissertation data frames columns of peak, this guy, peak power. Everything is very case sensitive, so I just find it easier to copy and paste everything that it already inputted itself, otherwise get some hassles. And now this is what the new data frame looks like. Dissertation PP. Perfect. Now is finding the difference between these two variables. So in order to do that, I need to specify my data frame that I want this to be done on. and I need to create, within that data frame, I'll create a new column. No, I need to use this. I'll create a new column that's showing that this is my the data within this column is my differences of the PP peak power variables, and now to actually do the difference, I'm just minusing the two columns from each other. Specify. Okay. Minus PP there. And now I'll just run this. So this is the first error that has popped up, and this is actually because it's recognizing that I want to subtract two different columns of data uh, within my original data frame, which it does not like. So in order to change this, I usually will actually create a copy of this data frame using the original data. So I just input taking these. Oh, I can just take them from here. So that top one is just saying create a new copied data frame, so that all this work is done on the copied one. And here we have it. We get the now change in PP column. And now from here, the next thing is I need to create another data frame. This is all just formatting everything so it is easier to work with later down the line. And we'll call this one correlation analysis, because this will only include my muscle mass muscle mass columns of data, and my dissertation, my change in peak power column of data. However, since they are from different data frames, I have to use another pandas function in order to specify that I want this column of data from this data frame, and I want another column of data from a different data frame. So here, because above we want to take this column, which is originally from just the dissertation data frame, and we want to also add in this column into this new correlation analysis data frame. But however, this one is from the dissertation PP data frame, and this one's from this just dissertation data frame. So this is only me specifying that I want to take this guy from the dissertation data frame, and I want to take from the dissertation peak power data frame, I want to have this change PP data frame. All of this can actually just be done within the same kind of line or string of code. However, I just find it just becomes very wordy and it becomes difficult to follow. Now, very quickly, I can create a scatter plot between these two. So in order to do that, I've got a got to specify that in this variable actually, I would like to use the data frame within this variable, and I'd like to plot a scatter plot where my x-axis is the muscle mass percentage variable, muscle mass percentage column, I mean, and the y-axis is my change in pp column of data, and this should come out like this. And very quickly, you can also do change the labels and stuff on these columns. So I'll just copy this guy over here, and just to quickly show. So if I want to change the x-axis label, I'll use this function. And I want to specify that my x-axis is now going to be referred to as, say, muscle mass percentage. Along with this, I can also give my scatter plot figure a title, where I now use this title function. And this is very reproducible with other figures. I did a bar chart and managed to use a similar kind of functions, the same libraries to change and format the figure. So relationship between muscle mass and peak power is what I will call my this figure. That's its new title, and I can also change it, make sure it's font size, because it originally comes out with a small font size, and this is just making it a nicer font size. So the x-axis label, so changing that can also be done for the y-axis, where I just change that x to y, and it's very fun to do actually. And the next thing is actually creating a I can put a trend line, which in this case I will need to use my Seaborn library, which I have abbreviated to SNS. So to start it off, I'll go SNS dot, and this is now giving a regression plot. I mean, like a trend line to the figure. Specify that these are my graphed data. These are the graphed parts of my data frame, and I need to specify that my data will be from this variable's data frame. And the marker is just keeping these guys. And yeah, there we go. And now this, of course, I can just copy and paste these guys in again to give it its title and its changed x-axis label. So now we have all that. However, you'll notice that this blue underneath, that's actually the confidence interval of the it's automatically given itself a highlighted confidence interval. So if I want to actually remove that, I had to do a bit of research on how to do this, is I will now have to specify a new kind of command where give no confidence interval. And that creates that. And yeah, but I can actually, I'll keep that there. And now I'll actually be demonstrating how to find the Pearson's correlation coefficient and the significance, the p-value associated with it, which I will be using a different library in order to do that. This function will be from the Skippy stats, uh, which we want to find the R value and the P value. This is what we will be recognizing them as. I'll put the comma. And so first thing is we want to use from the Skippy stats, which I haven't imported yet. And I've got a dedicated copy and paste for that, so we can import it. And now we are doing a correlation from this data of this against this. And this should provide, so that's done a correlation, and I haven't printed actually the result, so that's where I would need to use this print. And if I want correlation coefficient, now we use these numbered brackets. This is how I learned how to do it from the course I've been taking. And I have yet to find other ways to do it, more efficient ways. And so I still believe this is the best way to do it. Free F, the other one. And there we go. Now we've found the two correlation coefficients. Perfect. Above, I've also added a trend line to this data. However, you can notice all this blue highlighting, which we do not want. And actually, we can also bring in our titles stuff to this. There we go. But this blue highlighting is actually because it's highlighting the confidence interval for the data, which to remove that, I found I just do hue like this, and I believe no, I specify confidence interval and I go none. There we go. And this is because that isn't actually a capital. Yeah, there we are. And yeah, that's my demonstration of how I managed to find a Pearson's correlation coefficient and p-value for the relationship between my muscle mass percentages of my participants and their differences, their change in peak power between the experimental and control conditions, as well as how I can produce a scatter plot with my current knowledge of using Python to do statistical analysis. Thank you.